Great to be here, and thanks for the invitation. I saw my friend and colleague here at Rice a little bit earlier this morning, Kirsten Oster. Did you see her, Kirsten? There she is. I think she's maybe the reason why I'm here today, so thank you for the invitation. Looking forward to the chance to share with you just some work that a couple of teams that I work with have been working on, and sort of interested in sort of thinking about the ways in which we are all beginning to think about the sort of rapid sort of change and adoption of artificial intelligence in the clinical environment and what's at stake as a result of that. So just as by way of background, as was noted, I'm one of the principal investigators at the University of Texas at Austin, which is a part of the Good Systems Grand Challenge. A lot of the work that I'll talk about today, some of the work that I'll just mention, is informed significantly by Good Systems. Good Systems is the campus-wide kind of multidisciplinary initiative that's designed primarily to bring scholars together to address issues around sort of ethical and responsible artificial intelligence. Some of the work that teams and I have done, for instance, are sort of experimenting with generative AI chatbots. In this particular study, for instance, looking at the role of rule-based chatbots in addition to generative chatbots, and comparing and contrasting how well, how ethical, how responsible, how empathetic they respond in the context of maternal health and postpartum depression more specifically. Our teams have also worked with large data sets from the National Institutes of Health, like All of Us. Some of you may be familiar with All of Us. In this particular study, for instance, we were interested in looking at the degree to which social determinants of health may be predictive signals of a mental health, a major depression disorder diagnoses. And so in this sense, trying to understand which social determinants of health, how they distribute across different populations in terms of demographic features, and how that might be sort of predictive of mental health outcomes. Also working on another NIH-funded study with colleagues from the University of Texas at Austin and the Cornell School of Medicine. In this case, using natural language processing to sort of understand the ways in which social risk factors may be predictive of suicidal behavior. And in this particular project, we were particularly interested in the behavioral health crises facing young people and sort of rising rates of suicide, and looking at different kinds of data sets, primarily a national death reporting system, and sort of mining that data to see if in fact we could identify if there were specific social risk factors that again may be predictive of suicidal ideation, even suicidal behavior. More recently, the IC Squared Institute did a statewide survey of clinicians, safety net clinicians across the state, safety net healthcare providers, really trying to get a sense of their perceived risk and opportunities associated with artificial intelligence. And so it was a nice opportunity for us to sort of just check the temperature and the pulse of how clinicians are beginning to sort of think about and navigate this really interesting and ever-changing, ever-evolving environment. And then at IC Squared, we also partner with the Dell Medical School, sort of co-funding a number of PIs who are looking at various, across different specialty areas, looking at some of the ways in which AI and machine learning can be deployed to address a variety of different sort of clinical conditions, but also thinking about applying AI in ways that are ethical, applying AI in ways that are safe, applying AI in ways that are responsible. So the point here, right, is just to give you a sense of just the range of work that we do, from computational modeling to qualitative and survey research, collaborating with a variety of different sort of expertise in terms of the research that we pursue. The project that I want to sort of focus on today is a relatively new project. We started this project in earnest at the beginning of the year, but it's really kind of been, I think, a couple of years at least, if not more, in the making. And more specifically, I think like a lot of us here, and certainly beyond, this project is designed in some ways to begin probing with some degree of depth and rigor, this relationship between human intelligence and machine intelligence. And so we've started conducting a series of interviews with clinician researchers, really trying to understand how they are both integrating AI into the clinical workflow, and then what are some of the cognitive sort of practices and some of the cognitive models that they're deploying as they begin to think about what's at stake here, and as they begin to think about their own relationship in terms of clinical decision making, in terms of their own sort of human intelligence and expertise vis-a-vis the kind of machine intelligence that's also available to them via large language models, generative AI, for example. So here are just some of the questions, a sample of the questions that we're exploring, and I'll try to address a number of these questions today. How are clinicians adopting and deploying large language models in clinical decision making? What specific skills are emerging as a result of adopting large language models in clinical decision making? And what do these practices suggest about the relationship between human intelligence, machine intelligence, and the future of clinical decision making? So this work has been informed by a lot of the sort of developments that have really sort of accelerated, right, since ChatGPT was introduced in November of 2022. It's quite striking, right, just the sort of rapid adoption curve that we've seen with ChatGPT and its various applications in many different sectors, including, for example, the healthcare sector, the healthcare environment. As within a few months of ChatGPT being released, there was the New York Times study, for example, about clinicians using ChatGPT to help them cultivate and develop better bedside manner skills, suggesting, right, a sort of a recognition that ChatGPT and generative AI could be an instructional, kind of educational tool that might help them better sort of develop communication skills in terms of their interactions with patients. We know, for example, that there have been a number of different sort of focus areas in terms of this research, looking at clinical practice, looking at the implications for medical education, and of course, sort of looking at medical research. And what I wanted to focus on today in this talk is how we're beginning to think about the state of clinical decision-making, or the ever-evolving state of clinical decision-making, again, in the context of AI-augmented clinical environment and what that means. And talking directly to clinicians who are also researchers who are experimenting with these technologies. And so in some ways, we think they sort of represent kind of the frontier or the edge of how we're beginning to understand what's at stake, how we're beginning to develop a basic set of principles, frameworks, guidelines, and ultimately, hopefully, right, models and governance mechanisms to help sort of manage these processes in a much more effective way. I should also note that another sort of separate body of literature that we've been looking at in some ways sort of pivots around this ongoing kind of conversation between AI as a force for automation versus AI as a force for augmentation. And that is to say the degree to which AI, as it gets sort of integrated into various kinds of workflows, again, just what is the sort of discernible impact of these technologies. We are all very familiar with the sort of ongoing narrative that AI is here to take our jobs, that the machines are coming for us, and that we're all at risk as these technologies become more and more capable, able to perform decision-making tasks, able to perform a variety of tasks that are more cognitive in nature that just a few short years ago would have seemed like science fiction, but in fact are becoming more and more real. But one of the things that's really interesting in this literature, at least one of the sort of emerging consensus that I find quite striking, is an attempt to not only think about AI as a source of augmentation or a source of automation, but also think about AI as a source of sort of new task creation or new skill creation. Again, I think there's general consensus that in many instances, it's not so much that AI will take over entire jobs, but rather that AI will increasingly take over some aspects of our jobs, right? So it's this idea of task encroachment that a lot of researchers are beginning to study with some degree of detail in terms of trying to understand some of the very specific and precise ways in which AI is sort of being integrated into various workflows, including the clinical workflow, and what that means in terms of what work might look like, the future of work. And so from our perspective, the future of work, no one can predict that. What we can sort of likely predict, right, is that AI will obviously, right, in some cases, began to absorb more and more jobs, but it will also create jobs that we likely today can't even imagine. And so in that sense, right, it suggests that there's a really interesting sort of dynamic at play here, and we're all kind of experiencing it real time. But the main point here, right, is thinking about, again, what's the human premium in an AI augmented environment? What skills, what expertise, what experience do humans bring, develop, cultivate, historically and contemporarily, that are difficult for machines to replicate, right? And so that's one of the things that we've also been trying to understand in these research interviews and conversations that we've been having is what's still unique about what humans bring to the clinical enterprise that's quite distinct, right, from what machines might bring. So here are sort of 4 themes that I'll focus on today, kind of move through each of these relatively quickly. I could sort of spend the entire presentation just on one of these, but just to give you a sense of the range or the scope of topics that we're beginning to think about in the context of this work. And I should also say, right, that this is work that we are actively kind of currently engaged in. These are all sort of preliminary reflections, preliminary thoughts as we continue to think about the data, as we continue to conduct more interviews. But we have some themes and ideas that are beginning to emerge, and I wanted to share at least some of the preliminary insights that we're beginning to develop. Again, recognizing that these are all sort of fluid and emergent as we continue to do this research. But thinking about large language models in the context of diagnostic reasoning, thinking about large language models in the context of management reasoning, also looking at patient adoption of large language models, and what are the implications for clinical decision making, what are the implications for how clinicians are responding to increasing recognition that these are tools that patients are also using, and what's at stake as a result of that. And then thinking about some of the future applications of large language models in the clinical enterprise, and what that means for clinical decision making. So obviously one of the first and most important skills that a medical student develops, right, are the techniques that enable them to sort of perform and conduct diagnostic reasoning with some degree of reliability and a high degree of accuracy. This is in some ways a classification task that's quite important. And it sort of requires a number of different dimensions, right? Mastering a number of different skills, mastering a number of different components to be able to identify a constellation of symptoms, understand the patient, how those symptoms are presented, understanding the patient's history, the patient's story, a variety of things, right, to come into play in terms of being able to ultimately sort of engage in a kind of differential diagnoses, sort of developing a selection of illness scripts, and then ultimately sort of identifying sort of a diagnosis that then serves as sort of basically the catalyst for how you then pursue and develop a management plan. How do you respond to treat and help that patient recover for whatever condition or illness that they may be suffering from? And again, this is a relatively complex process and one that is quite essential, right, in terms of the clinical enterprise. And we know, for example, right, that diagnostic errors are unfortunately a relatively common phenomenon in the clinical enterprise, and it can have significant impacts, right, on quality of life, significant impacts on life specifically. And so in this sense, diagnostic reasoning is obviously, right, a very important sort of element, a very important aspect of clinical decision making. Some of you might be familiar with this study that was published last year. And in this study, the researchers essentially did an experiment where they created, I think it was like 5 or 6 clinical vignettes. And then they basically set up an experiment where one group, for instance, was just clinicians who were using kind of their own expertise and maybe conventional resources to try to arrive at a clinical diagnosis based on those vignettes. Another group of clinicians sort of were sort of partnered with an AI, a large language model, to see if that might assist or impact or enhance their ability to do clinical reasoning, in this case, diagnostic reasoning. And then they had just AI alone, right? Also analyzing, surveying, and then sort of generating some type of diagnostic result from these vignettes. And what they found, right, which I think was quite surprising, at least initially to the researchers themselves. Now obviously, right, if you think about these 3 different, elements in this study, I think most of us would think that the human plus AI would be the better performer, right? The one that would achieve greater accuracy, more reliability, results that we could trust, and sort of basically identify that as the preferred sort of approach, the preferred sort of situation for doing clinical reasoning, in this case, diagnostic reasoning. But what they found, right, was something different. They found that the AI actually performed much better than the AI performed much better than the AI plus human, and it performed much better than just humans, right, trying to solve this without any kind of large language model support or assistance. And I think they were surprised by the results. And the results led to a number of headlines like this one: AI chatbots defeat doctors at diagnosing illness. And it was really sort of an interesting sort of buzz, if you will, in terms of at least this kind of concern, anxiety, surprise about machines outperforming humans, but also machines outperforming humans plus AI. And that, I think, was the sort of surprising dynamic here. But if you begin to sort of read some of the fine print, and how the researchers began to sort of analyze their results, a slightly different story emerges here, right? And it wasn't so much that the AI alone was superior to, for example, AIs plus humans, but rather the ways in which humans interacted with AI in some ways diminished their ability to deliver a much more accurate diagnosis. So in many instances, for example, they found that clinicians sort of rejected or ignored some of the recommendations or some of the outputs that were generated by AI. And so from their perspective, right, if clinicians had collaborated with, if clinicians had interacted with, if clinicians had taken seriously some of those outputs and recommendations, and then combined that with their own expertise and experience, then maybe their performance would have been just as good, if not better, than the AI model alone. As we began to talk to clinicians about this dynamic, about this aspect of integrating AI into the clinical workflow, and I think diagnostic reasoning is one of the sort of early use cases that we're seeing, a lot of experimental studies in this particular instance, a number of different sort of interesting conversations and developments around this particular dynamic. And one of the things that we're hearing from clinicians, right, is sort of a recognition, almost even a sort of submission, if you will, to the idea that if not today, tomorrow, or certainly in the near future, that large language models will be as good, if not better, as their human counterparts in terms of diagnostic reasoning. And so some doctors have suggested to us or said to us in these words, for example, as one clinician said, if AI can perform diagnostic reasoning better than I can, don't I owe it to my patients to use it? In other words, right, if this is something, right, that can enhance clinical decision-making and more importantly, enhance the quality of life of a patient, then it's something that we have to sort of significantly or seriously consider. As we begin having these conversations, one of the things that we're also trying to track are what new or enhanced skills are emerging as clinicians began to interact with and experiment with large language models in the context of clinical decision-making. So for example, in the case of, let's say a clinician is opting to use a large language model to support their diagnostic reasoning, here are some of the things that they might want to develop. Using AI as a collaborator and thought partner is a sort of interesting concept that's beginning to emerge over and over again in many of the interviews that we're conducting. But what we find striking here, right, is that the clinician researchers that we've been talking with and interviewing aren't necessarily using large language models to give them, quote unquote, the right answer. Instead, they're using large language models to sort of refine their own clinical decision-making process. In some ways, right, as a tool or as a resource to enhance how they go about making decisions. In some ways, sort of diagnostic refinement is really what they're looking for. And we think this is really interesting and a subtle but a really interesting point here. And so in some cases, right, what we're hearing are cases and examples of clinicians who are using large language models, for example, to expand their diagnostic reasoning toolkit. And so we think this is a really interesting approach, and in some ways, suggests something that I'll mention a little bit later, as thinking about the kind of mental models. I mean, we all develop mental models as it relates to, for example, AI, as it relates to even more specifically generative AI and large language models. Some of those mental models are more favorable towards LLMs. Some of those mental models are more negative or unfavorable towards LLMs. And those mental models in some ways orient us or position us in ways that then influence the decisions that we make, the choices that we make, and how we integrate those technologies into our workflow, whatever that workflow might be. And this is certainly the case with clinicians. But here's an interesting quote. So as you can imagine, right, even as clinicians recognize the growing sort of capabilities of large language models in terms of diagnostic reasoning, they're still concerned, right, about the degree to which this technology might in some ways serve to automate this process, if not disrupt it entirely. And so this is a quote, right, that suggests that a huge concern in terms of how reliance upon diagnostic reasoning may lead to dependency, how it may lead to the underdevelopment of what a number of clinicians refer to as their cognitive muscle, that is to say their capacity to sort of think through and to sort of struggle with arriving at a decision that's relevant and most notable for their particular patient. And so in this sense, right, in this quote here, the idea of just going to a large language model, right, to get the answer without engaging in some kind of cognitive process, some type of cognitive labor, is something that they find is a disservice to the profession, and in some ways something, right, that is quite disturbing. And so if you think about, right, the future of medical education, right, this is something that's also coming up in a number of the interviews. How do you begin to train and educate the next generation of clinicians, right, in this environment? What we're hearing, right, is that medical students are coming in already using these tools, already using large language models. And so that's not really a question. It's not a if they will, they already are. And for many medical schools, right, is how do you build curriculum? How do you build instructional environments that recognize this, but still help students build foundational knowledge, right? That's quite critical in terms of developing some of those important sort of long-standing skills related to performing diagnostic reasoning. We've also come across researchers who have been thinking about the application of large language models in the context of management reasoning. So if you think about diagnostic reasoning, right, it's a classification task. Typically, right, there's a correct or incorrect answer. Someone could have comorbidities, there could be multiple things going on, but ultimately, right, a diagnosis, right, is intended to sort of identify specifically what condition the patient suffers from, and then how do you begin to sort of develop, right, a management plan to address that. If diagnostic reasoning is a classification task, management reasoning is what we might call an optimization task, right, and that's very different. In other words, right, in the context of management reasoning, right, the patient could present, right, with the same diagnoses, but how you manage that patient, right, could be very different. And that's where you begin to see the nuances and the complexities of management reasoning coming into play here. A number of factors, right, sort of determine and impact how you manage a patient. That patient's health literacy, various non-medical factors that are sort of impacting that patient's life chances and health outcomes, whether or not the patient has medical insurance or not, if they have social support, the healthcare system and the clinical team itself. These are just some of the sort of factors that a clinician has to begin to start thinking about and managing as they develop a plan to sort of respond to and take care of their patient. Another way of thinking about this, right, is that in many instances, management reasoning is also shared decision-making. Right? You don't necessarily, when a clinician is working with you to sort of diagnose what's happening with you, they aren't necessarily, making that decision sort of in collaboration with the patient. They have labs, they have examinations, they have processes and protocols that help them do that. But when developing a management plan, right, you likely are sort of working with that patient, partnering with that patient to sort of figure out what is the best path forward, collaborating with other members of the clinical team to sort of figure that out. And so management reasoning in some ways, right, is a very different dynamic compared to diagnostic reasoning, and in some cases, right, much more complex, right, in terms of the different factors and nuances that are at play here. So here's another study, a relatively recent study, where researchers similarly ran an experiment where they were basically looking at clinicians who had sort of traditional resources versus clinicians who were working with large language models, giving them a series of sort of scripted vignettes, and then seeing what kinds of management decisions they might make based on either sort of working with more conventional resources versus working with large language models, for instance. And a really interesting a study and one that I think is worth looking at. I mean, what they found is that those clinicians who were, for instance, sort of partnering with large language models were making management decisions that were much more responsive, what their sort of evaluators considered much more effective, sort of reasonable management plans to pursue. They also found things like those clinicians who were working with large language models in terms of addressing these management tasks also spent a little bit more time, right, in terms of their process, a little bit more time in terms of how they were reasoning, and they felt that that also contributed to better outcomes in terms of the results here. And so what they found, right, is that our findings demonstrate that decision support, even in a task as complex as management reasoning, represents a promising application of large language models that requires rigorous validation in real clinical settings to realize its potential for enhancing patient care. And this is a really important point, right? Application of large language models, rigorous validation in real clinical settings. I should be very clear, right, that of all the sort of clinician researchers that we've talked to, they're largely sort of working with large language models, experimenting with large language models in a research context, as opposed to a real world clinical context. And that's very different, right, and very important to make, a very important distinction to make, because virtually all of them have said to us, first of all, there's no formal mechanism for integrating large language models or generative AI into the formal clinical workflow. And there, of course, are any number of governance and ethical issues that are at stake, right, that still need to be addressed, that still need to be developed. And so in this sense, right, what we're really looking at, right, are experiments. What we're really looking at is research, really trying to help point the way towards what a possible future might look like as it relates to these technologies. And we think that this is really important. A number of clinicians have suggested to us, right, that they find this task, management reasoning, a pretty significant high bar for generative AI and large language models. They're not yet confident, they're not yet convinced that large language models in a real clinical environment could be as effective as a human doctor. And this is sort of one of the ways in which humans begin to sort of separate from machines in terms of what makes us unique, in some cases maybe even superior to machine intelligence, right? So this idea, right, that a human professional has a certain kind of expertise that machines simply don't have. They can understand context. They can understand, right, all of these sort of non-medical drivers that may factor into a management plan. They understand, right, what the payment system is. They understand their healthcare resources, their clinical team's resources, and how all of those factors will influence the management decisions that they make. And so imagine, right, trying to develop some type of algorithmic procedure to sort of manage those kinds of nuances, those kinds of factors. It's a really high bar. And for many of them, one that they think that at least for the near future will be difficult, right, to really assign AI the capacity to do that. I don't think it comes as a surprise to anyone here that a number of patients, are using large language models for second opinion. They're using large language models to get feedback or answers about symptoms that they may be presenting with, if it's them or a family member or a friend, that increasingly, right, patients are beginning to see this as a resource for their own health information seeking behavior. And this is something that's become really interesting. So in this quote, for example, 100 million people have ChatGPT on their phone and are asking questions right now. People are going to use chatbots with or without us. And this is absolutely true. This is already happening. We hear from virtually every clinician researcher that we talk to that they've encountered patients who bring in a log of a conversation that they've had with chatbot, a second opinion, or what chatbot says is going on with them, and how should their doctor respond to what chatbot has recommended or suggested in terms of diagnosing them, in terms of managing them, a really interesting sort of dynamic that's emerging here. This, of course, isn't new, right? One of the earliest sort of use cases of Google, one of the more enduring use cases of Google, almost from day one, right, was end users using Google, right, as a health and information seeking resource, as a way to, the term Dr. Google, I think we're all familiar with. And so it suggests, right, that patients have always had this inclination to turn to it and rely on digital resources as a way of sort of externalizing their access to information. And what many have suggested, right, that there are both pros and cons associated with this, right? The idea that it provides greater access to health information that prior to this era would have been largely difficult for most people just to find and access this information. But there are also certainly challenges, right, and some that come up in the research that we're doing in terms of quality of that information, in terms of misinformation, in terms of health literacy, in terms of being able to sort of navigate this information environment in a way that's effective. Some of you may be familiar with the Kaiser Family Foundation study that was released, I want to say early 2024, if I'm not mistaken. And in this particular study, they were essentially sort of looking at the increasing number of people who were essentially using generative AI, large language models, indeed in this way, right, as a health information seeking resource. And so they found, for example, that 1 in 6 adults say they use AI chatbots for health information and advice at least once a month. And so again, this is a common practice, and we can anticipate, right, that this will become even more common, right, that this will become routine, and that in some ways, right, is something that doctors are beginning to understand, and it's requiring them to make certain adjustments. It's requiring them to develop certain kinds of proficiencies in terms of responding to patients who are coming in having had these kinds of encounters. What's also really interesting here is something that Kaiser pointed out, is that one of the dilemmas associated with more and more people going to chatbots, for example, for health information, is that they're oftentimes uncertain about the reliability of the results. Right? And so if you compare, health to practical tasks or technology, health and politics, right, they had less trust, right, in the results and outputs related to those two categories. So suggesting, right, that even sort of everyday end users sort of recognize that there are some complications, recognize that there are some significant challenges as it relates to the adoption of AI in this context. And so in this quote here, again, one of the clinician researchers sort of indicating, right, the degree to which they are beginning to confront or encounter these kinds of experiences and what it requires from them are things like, using patient large language model engagement as an opportunity for health literacy, consultation and prompt engineering. So for example, what many clinicians will tell us is that one of the problems that they face when a patient comes and presents information from, let's say, ChatGPT, is that the patient has sort of wrongly input, right, their medical condition. And so in some sense, right, ChatGPT is responding to a case that really isn't their case or situation. Therefore, right, the results and outputs just aren't relevant, right, to that particular patient and his or her condition. Advocating for critical discernment, that is to say, for instance, encouraging patients to think more critically about these outputs. And so this, again, right, is sort of an interesting, set of, skills and proficiencies that clinicians are having to develop as it relates to AI. So I want to wrap up here and leave some time for questions and think about the future application of large language models in clinical decision making. We're seeing more and more of a trend towards embedding generative AI tools in electronic health records, for example. And so this idea of agentic AI, this idea of AI sort of initiating, right, interactions with the user. In this case, right, initiating interactions with the clinician, providing them easy access to a variety of resources and information within the electronic health record. We know, right, the sort of historical problems that clinicians have had with electronic health records. Some have referred to the condition as sort of a clipboard junkie, right, that they're just constantly clicking, sort of trying to find information, how time consuming that is, how draining that is, how in some ways it degrades the sort of clinical practice itself. And the promise of embedding these solutions in electronic health records is that it will render that process much more efficient just by voice or just by perception, right? You can sort of find information more easier rather, and then in some cases, right, AI may begin to understand, right, what you're looking for, anticipate where you are in the clinical workflow, and make suggestions or references for you in terms of its own agentic capabilities. As you can imagine, this is something too that clinicians are beginning to think about. And in this quote, right, we're all, I think, likely familiar with ambient listening AI, right? The degree to which this is, I think, one of the early and most frequent sort of use cases in terms of AI being adopted in the clinical workflow, in the clinical environment. And so you can imagine, right, as AI gets more fully integrated into the electronic health record, beginning to sort of understand what does that mean in terms of the cognitive labor, the sort of cognitive work and engagement that a clinician might practice. And so we're hearing some really interesting, although they certainly understand the benefits of ambient listening tools, clinicians are also articulating what they consider some of the concerns, right? The degree to which it's automating a task, right? If it's note-taking, and for some, note-taking, right, is a part of their cognitive process. It's how they think, it's how they understand their patient, it's how they generate questions, it's how they generate insights. In other words, right, it's a form of cognitive engagement that's really important to the clinical process, and for them, the worry is what happens to my cognitive capacity and my cognitive engagement if I begin to defer more and more of these tasks, right, to machine intelligence. And so in that regard, as we begin to think about the embedding of AI solutions, generative AI in the electronic health record, what's at stake here in terms of, clinicians being able to maintain some degree of agency and some degree of engagement in terms of the clinical process itself. In this study, for example, some of you may be familiar with this study, but this is essentially using chatbots, for example, using large language models to respond to patient inquiries. This is something that also comes up over and over again in our research, right? Is patients have questions after a visit. Patients have questions after a procedure about medications, about how their body's responding, about appointments, et cetera. And so using AI as a way to sort of respond to those patient inquiries. And what this study suggests, right, is that when clinicians just simply use the output that AI generates, it can oftentimes make mistakes. And so the need for patients to use these kinds of outputs to inform how they communicate, as opposed to using them exclusively for communication. And so in that sense, suggesting, right, the need to exercise some degree of agency, some degree of control, some degree of influence over how you're interacting with and deploying the sort of outputs that are being generated by AI. And then just a few final comments. I was particularly struck by this study, and this is something that we're interested in, is really trying to figure out empirically how we can understand how clinicians are actually interacting with large language models, right? And so these experimental studies have been good, but they've primarily been around related to trying to understand accuracy, sort of comparing and contrasting AI versus humans in terms of what's a more accurate outcome, what's a more accurate result, and that's obviously really important. But also important, right, is sort of understanding the sort of behavioral sort of conditions, the behavioral sort of dynamic in terms of how clinicians are interacting with AI, how they're interacting with large language models. What decisions are they making? How are they prompting? How are they pushing back? How are they critiquing? How are they sort of finding their own voice, their own sense of agency in this dynamic? And in this study, for example, they did something very similar to this, and they came up with sort of 4 typologies, right? So they gave researchers some information, some vignettes, and then asked them to either do management reasoning or diagnostic reasoning. Some clinicians in this study were what they call copy pasters. They just copy and pasted everything and dumped it into the large language model. Some were selective copy pasters where they selected things that they thought were more relevant. Others were what they call summarizers, where they tried to summarize in their own words what was happening in the sort of vignette, and then trying to get AI to respond to that. And then others were searchers, right, where they basically sort of used large language models as a kind of a search engine, as a mode of inquiry and discovery. And so they sort of argued, right, that these are some ways of beginning to think about the sort of typologies, the type of behavioral characteristics that are emerging as we begin to understand what that human-clinician interaction with AI looks like. As I mentioned earlier, something that comes up invariably, oftentimes subtly in our research, right, are the sort of mental models that clinicians are developing. So this is really important. Mental models could be related to trust. Mental models could be related to a sense of efficacy. Mental models could be related to knowledge. Mental models could be related to how much experience they have with large language models. This is kind of a simplistic kind of mental model sort of graph, because there are a number of different factors that are likely influencing the mental models, right, that clinicians are developing. But again, just sort of understanding how those mental models in some ways position and orient the choices that they make, the sort of inclinations that they bring to large language model engagement, and then how that impacts and influences clinical decision making. We're also beginning to think about, right, where do these technologies sort of, how do they fit within the clinical workflow itself? So as you go through the clinical workflow, when is it most beneficial to interact with these technologies? When is it less beneficial? What are the circumstances and stakes? And so understanding, right, that not all moments or phases within the clinical workflow may be appropriate for using or beneficial for using large language models. And sort of understanding and making those kinds of decisions is another important skill that we think clinicians will need to develop as they begin to think about this technology. So this study, in some ways, I think sort of represents the kinds of things that we're looking for. Again, understanding which tasks large language perform well and don't perform well, which tasks require greater refinement and agency in terms of exercising a greater degree of control over how a large language model is making a decision or generating an output. And then understanding, of course, the sort of HIPAA-related matters as it relates to the integration of large language models into the clinical workflow. So what you can see here, right, is that there are a range of skills and proficiencies, a number of things that clinicians are having to think about and develop as they begin to experiment with these technologies. And what we find really interesting, right, is that, because these are mostly clinical research, clinician researchers working in academic sort of medical centers. And so they're primarily, right, in medical schools, so they have access to resources, have access to capacity, expertise. But what they currently don't have, right, are governance models or procedures to help them really sort of think about this in a much more rigorous and consistently reliable way. And so this, I think, is something that will be quite interesting. I'll wrap up here, but here's our team that's working on, one of our teams that's working on a lot of the work that I just suggested here. They're here and around today, so if you want to reach out to them, talk with them, certainly feel free to do so. I benefit significantly from working with them, and we're all excited about the work that we get to do and the work that's forthcoming. Thank you.
We have 5 minutes for Q&A. I'll take the first question. You didn't mention the H word, hallucination, which is we know the LLM 10 times to be just egregiously wrong. And how should we take into consideration, especially in clinical settings?
Yeah, no, it's a great question, and it's obviously right. One of the key factors that really prohibits any kind of formal integration of large language models, for example, in the clinical workflow, right? These systems still do this, they still hallucinate, they still make up things. We've had clinicians who have shared that this has happened with them, it's happened with patients, and so it's a very real challenge. I mean, the one thing about hallucinations, right, is that we should put in perspective is this critique or this notion of large language models and hallucination is obviously a common one, but we have to understand, right, what large language models are in essence, right? They're probability machines, not factual machines, right? So even when it's creating something that's not hallucinating, even when it's creating something that's reasonably accurate, it's still basically more of a probabilistic sort of output as opposed to a fact-based output. In other words, large language models weren't built to get things factual. They were built to get things that were probable, right, in terms of the kind of input or response. And so this is something that we sort of have to keep in mind. And so when we talk about these mental models, right, in this case that clinicians are developing with AI, sort of understanding that at all times, right, it's creating content, it's creating output that it ultimately really has no sort of in-depth knowledge about or experience with. And these are all probabilistic outputs that may or may not be relevant or reasonable or related to what you're working on, but not necessarily fact-based. And I think that's an important distinction to make.
Other questions?
Hi, thank you. Thank you very much. It's very insightful information that you shared with us. My question is that how AI and LLMs can assist in the ER environment. Thank you.
How they can, so I'd love to ask you that question, maybe afterwards, in the ER environment. Yeah, I think it's, so this is a little side note, but I think it's response to your question. So how many of you have seen the television show The Pit? No one's seen it, okay. It's basically a show that's sort of situated in an emergency room. And there are obviously, shows like that that exist today. You're probably familiar, some of you may be familiar with the TV show 25 years ago called ER, that was similarly based in an ER environment. Having finally watched The Pit, what struck me is that I don't recall in any episode, and this is a very contemporary show, post-COVID even, and that's part of the storyline, I don't recall anything about AI appearing in the show or any of the episodes. And I found that quite striking and interesting, right? Because all of the modern technology is there, but AI was never mentioned, it was never engaged. And I've thought about, why that is. And in some ways, if you think about the emergency room environment, right, it's fast moving, decisions have to be made almost, instantly, sort of real time. And so in that sense, in terms of, that clinical workflow, it's perhaps maybe just sort of structurally difficult to sort of integrate AI into that environment in a meaningful way. And I could be completely wrong, and there may be folks here, right, in the emergency room who might, dispute that or have evidence that would suggest otherwise, which is why I said I would ask you the same question, because that just struck me as really curious that in a modern TV show, right, that AI wasn't presented in any way. And I wonder, right, if the workflow, if the environment, if the fast-paced decision-making, if the real-time critical emergency situation requires a certain amount of human intelligence, a certain amount of human capacity to reason, to understand what a patient is presented with in terms of a constellation of symptoms. And in some cases, right, it's emergency, it's life or death, and decisions have to be made now. You can't ask ChatGPT, you can't type in a prompt, you can't ask a prompt, you can't pull out your phone, you have to figure it out. And you have to figure it out on the spot, real time, or literally, right, a life could be at stake. And so I wonder, and that's what we mean by clinical workflow, that's what we mean by the environment, the context, the conditions in which these technologies are used. In some conditions, in some contexts, in some environments, the conditions may be more favorable to using them than in others. And I wonder if the ER is one of those unique environments that still requires, right, human expertise, human intelligence, human innovation in terms of responding to real-time, in-the-moment crises.
But that's because we're still thinking that you're typing prompts and things like that. It shouldn't be too difficult to have voice recognition and voice generation.
Yeah.
Remember on Scotty on Star Trek saying computer and ask questions.
Yeah.
That should be very easy to implement in ER.
Yeah.
Just it's there, you just ask questions and it gives you answer verbally rather than we're used to the typed context.
Yeah.